Hi everybody. I'm just gonna put my full screen. I hope now it's working. Yeah, I think now it's working well. Hi everybody and welcome. So thanks a lot for this introduction, Torsten. Yes, so I'm at Formlabs. I'm an application engineer. I'm in 3D printing already for a couple of years, and today I'm doing some research on application workflow, so testing in-house and with customer workflow for new application for manufacturing and engineering for using 3D printing in those industries. So what are we doing at Formlabs? We create reliable and accessible 3D printing solution. Oh, sorry, I cannot switch anymore. Sorry, I just lost the page. Yeah, that's good. And yeah, we started at Formlab. We started the company in 2011 out of MIT Media Lab, and now we are more than 600 people. We had 6 offices. The general headquarters is in Boston. The European headquarters is in Germany, in Berlin. We have 3 factories, USA, China, Hungary, and we have more than hundreds of engineers and scientists. We manufacture in-house our hardware, our software, and also our materials, SLA materials. So we also have material scientists in-house. And we have sold more than 50,000 printers in more than 40,000 countries. So this really put us as market leader for professional 3D printer. So today I want to talk about first what's our Formlabs solution for manufacturing, and I will give some concrete example of application on how to use 3D printing for manufacturing tools. First, 3D printing jigs and fixture for work holding and finishing, 3D printed molds, and 3D printed dies for sheet metal forming. So first, an introduction on our product and how manufacturers are using it right now. This is a portfolio of our product. We have 2 different 3D printing technology, stereolithography technology, I will refer it as SLA, and a selective laser sintering technology, the Fuse one, which is still in development. Today, I'm going to focus on SLA technology, which is our core product with the Form 3. We also have the Form 3L, which is a large format of this technology with 5 times the build volume of the Form 3. And we also, as I said, we manufacture in-house our SLA material and our post-processing unit. So, quick introduction on SLA. I don't know if you're familiar with the process. It's a resin-based process. We have on the printer, we have an optical system with a laser that comes to a back of liquid resin and solidify the resin layer by layer. So the part, a solid part, is built layer by layer from photopolymerization. So the resin are very important in this process, and at Formlabs, as I said, we manufacture them in-house, and we developed different mechanical property and thermal property as well for those resin. We have a whole range of different kind of resin for standard product, but also dental product, healthcare, and special resin. And we have some engineering resin that have technical properties and are very useful for manufacturing application. In particular, our tough and durable resins family are very interesting. We launched them, we released those materials very recently, actually. The Tough 2000 and the Tough 15000 are one of our latest material. They are one of our most robust and most functional material in our library, and are very useful for prototyping, jigs and fixture, functional prototype, connectors, and also parts that handle wear and tears. That's very good choices for that. So you can see just quickly some different tensile tests here from those 3 resins. They are basically going on the spectrum of different impact strength and soft and stiffness. The TUF 2000 resin here is very similar to ABS. And then at the other spectrum, you have the durable resin that is very soft. I cannot move again. So what's our vision at Formlabs, and how do we want to make 3D printing accessible? So the same way that has been done for computing and going from a single large mainframe computer to multiple smaller servers and modular servers. In the same way, Formlabs is doing the same with digital manufacturing, and you can see here on this deck, on the left side, this printer is about 300,000 euros. For this price, you could have about hundreds of Formlabs printer, and you will have much more flexibility and modularity. So the idea is really to take the power of industrial SLA and bringing on the desktop with small, affordable, and modular units. So we have customers that are building what we call modular 3D printing production in-house on the factory floor. So it allows them to have a lot of scalability and flexibility. So you can start with a couple of printers, and as you discover more use case, more application in the factory, then you can scale and add incrementally as the demand grow and the market change. So this is really how we propose with modular production to do agile manufacturing. We have a lot of customers that will have a modular 3D printing production on the factory in the assembly, like next to the assembly line, and then also at department like prototyping or product design. Also for maintenance, so in different departments, so that really it gives a lot of flexibility in the product development process. So topic of this conference is really about digitalization. So additive manufacturing fits very well here, and it's a really great tool for digitalization for industries. If you're familiar already with 3D printing, you probably know that it's very useful for prototyping, pre-production, communication model, and manufacturing validation. Also in end use part is very popular, like mass customization and short series. Today I want to talk in particular about production tools and production aids, so how to use 3D printed parts as a step in the manufacturing process. So this is what we call hybrid workflow. We use a 3D printed part as an aid in the manufacturing process. So it's not about replacing traditional manufacturing process by 3D printing, but really enhancing this process with the flexibility of 3D printing. So I'm going to give a couple of examples of application on how customers are using SLA part today, how they're using a printer in hybrid workflow. We have, for each of these applications, we have some detailed webinars and white paper about it. So you can, if you want to have more technicals and more details and dive deeper into those applications, I really recommend to watch the webinars and the white paper for each of them. But right now, I really want to give an overview to let you know what is possible to do and what our customers are doing right now with SLA printing in the factory and in a step for manufacturing processes. So first, I want to start with using 3D printing jigs and fixtures in the factory. So this is an example of a customer from Austria that is called Penkel. They are manufacturing drivetrains for automotive companies, and they were facing the challenge of having to produce thousands of custom jigs for a single assembly line. And with 3D printing, those parts that you can see here in blue that they put in the assembly, so those are printed with the resin tuff that I was just talking about before. So with 3D printed these, they managed to reduce cost by 80% and lead time by 80% as well. So this was a really great added value for them. Another example is from the Advanced Manufacturing Research Centre in the UK. They were on a project that was under really strong time pressure, and they had to find a replacement part for a robot, so replacement robotic grippers. And this was for a project to manufacturing carbon fibers. So they had to align plies of carbon fibers in a very precise way. And they actually play on the advantage of the design of 3D printing, so being able to fabricate some specific lattice, and also the different properties of the material. So they needed some stiffness, but also some flexibility in the material to have the precision of the gripper. So they managed to do that with the material and the lattice. Another example from the Advanced Manufacturing Research Center was in the process of filament winding. So they were using custom jigs to have the different size of filament passing. So just some custom rollers that were also printed with the tough resin. And this really allowed them to have a great flexibility in the different filament that they were using for this process. This is an example here from Ashley Furniture, which is one of the leaders in furniture manufacturing. They are using actually 3D printing on the factory floor. So they have a large inventory system for jigs and fixture part and replacement parts in the factory. And they have been setting up more than 700 printed parts in the factory to work holder, part replacement, any kind of tool that were basically improving efficiency and work labor. Last example for jigs and fixture as work holder. So this is an example of a new tuff that I just wanted to show on the big manufacturing machine that is for metal bending. This is so AccurPRESS in the US, who was manufacturing one handle for this machine as a replacement part. So this is to talk about how to use jigs and fixture or 3D printed parts for finishing. So for masking, we have customer in automotive and aerospace using 3D printed part for masking process. So this is really interesting because usually manufacturer will use it use taping traditionally for that. They just will use tape for processes when they need to mask some parts when there is a treatment to apply. So for example, coating, paint, powder coating, or anything abrasive, any plating or bonding process. So when it has to be applied on one part but not everywhere, and traditionally we will be using tape, and now we have customers that are using 3D printed part, and it works very well because it's really scalable. It's something you can take in and out, and it really reduces labor work. So now I want to talk about how to use 3D printed mold for manufacturing, manufacturing validation and short run production. So in most of manufacturing process, committing to tooling will be the first pain for lead time and cost. So this is why we propose to find some alternative tooling method. So for example, with injection molding, we have customers that are using our material to actually validate a mold, so either to prototype or test a mold before committing to an expensive mold in metal or in plastic, but before committing to manufacturing an expensive mold, but also for short-run production. So we have a special material, so this one is not the tough and durable family, it's called high temp material. It allows to go to very high temperature, and this allows customer to do injection molding. So the number of iteration really varies depending on the geometries and the pressure injected in the machine and so on. But we really recommend, we have done some tests and we have customer that goes from a couple of iteration to maybe 50 iteration. We will recommend to really use it for under 10 iteration probably to test the mold. We also have customer using, again, this resin, high temp resin for thermoforming, so creating mold in particular for packaging. So this is one of our customer called Quip that is doing some toothbrush product and is using this for packaging. Silicone molding, so we have a great white paper about silicone molding, so I'm not going to go into detail right now because the process is quite long to explain, but we have a few different steps and 3 different methods implemented to be able to do silicone molding. One is compression molding. We also have some casting process for silicone molding, and also overmolding. So another application I want to talk about is for composite molding. So this is an example of a case study where we have a customer, Delta Wing, that was producing air part component for a racing car company called Panos. And they have tried 2 different processes. One process for composite manufacturing where it's printing pattern. So you can see on the left side, it's again printing with high temp. So the concept is to print a pattern, then cast a mold out of the pattern, and then apply the traditional composite molding process. So you can cast the mold, and then once you have the mold, you apply the carbon layup, the pre-preg layup process, then the vacuum bagging and demolding, as you can see in this picture, and finally is trimmed and assembled. And they were also using another method. So this was direct printing. So you just have to delete a few steps from the process I just explained, and you directly print the mold to create the carbon fiber part. So this is an exit air. And this one was interesting because they only needed 6 cycles for this part, only 6 parts. So they could directly print the mold. They print it in 2 parts, and they could directly apply the vacuum and autoclave curing process. We also have some resin that are used to do direct investment casting, in particular for jewelry, but also for industrial casting. So we have a resin called casting wax, castable wax, which really works as a usual wax used in jewelry, and this allows to really manufacture metal parts. Same with sand casting. We have some application with using sand casting for this in the process of doing metal parts. And still in the metal manufacturing area, now I want to talk about forming sheet metals with 3D printed dies. It's quite a new application that we're presenting. We have been doing a webinar about it a couple of weeks ago, so a very interesting webinar. The idea is really to replace a metal die used in sheet metal forming with a 3D printing die. So sheet metal forming is really everywhere in our daily life. We have sheet metal part everywhere. It's a very cost-effective method. There's very little material waste. And here you can see on this picture a picture of a sheet metal louver. This is just an example. And again, as for other injection molding process or carbon fiber layup, the tooling part is always very generating a lot of cost and a lot of lead time. So we thought about, so we have an engineer, a lead engineer in house that has tried some tests to propose alternative method in tooling, tooling with 3D printing. So you can see here on this little video, this is an example of a part that he has done, which is a blade guard of a sawzall, actually electric saw. And you see this is a pretty simple design that that he wanted to try, but has actually a couple of complicated features. So in particular, inside here, there is a formed radius that is not that easy to do with forming. So in the webinar, he's explaining what are the challenges in designing. So designing will be really the critical part of this process, designing the die for sheet metal bending. It's in general very important for sheet metal bending to design with the right specification. But yeah, he explained everything in the webinar, which is really interesting. And he was using our rigid resin this time. So it's again one of our technical resin, which is our stiffest resin. It's actually probably one of the stiffest material in SLA and in 3D printing. And it allows actually to really bend sheet metal with this die. So you can see here the process. You have the lower die here and the upper die here. This is the part to actually bend some flanges around the part. And then you have a second step that is to form the inner feature. So how to form an inner radius around a hole. And this is also just applying the dies inside a hydraulic press. And this allows to really create some really good quality parts, so really close to production quality. And this is great for prototype if you need to prototype your sheet metal part, or if you need to prototype your die before committing to a very expensive tool, but also for short run production. So we haven't done yet some tests on how many cycles you can do with one die, but it looks like you could really do a couple of iterations, and that could really be very interesting for short run production, even more than for prototyping. So first prototyping the sheet metal die and the die, the sheet metal part, sorry, and the die, but also short run production. Yeah, this is it for this presentation. Thank you very much, and I think now this is the Q&A session.